friends, and today we are going to study a new topic, that is a time scaling of signals. Basically, time scaling means what? Time scaling means just a compression or expansion of signals. Compression means what? You are going to decrease the time period, and similarly in expansion case you are going to increase the time period. If the time period is decreased, then number of frequency will increase, and if time period is increased, then frequency will decrease. So you can achieve maximum cycles within a time per unit time, or minimum cycles within unit time, using compression and expansion. And this compression and expansion is much more useful in digital world. So right now, how this compression and expansion takes place, that we are going to study, and it is just because of time scaling method. So how the time scaling is done and what is the definition, that we'll study first. The compression and expansion of signals is called time scaling of signals. So there is one factor basically which is used to compress or expand the signals. That factor, let's say that name of factor is alpha. So that factor is scaling factor, and there are different conditions of alpha which is used for compression and the expansion of time signals. So let's note it down. Necessary, important, just listen. Necessary conditions for alpha. The first condition is, if mod of alpha. Why I have written mod? Because negative values may comes, that's why. If mod of alpha is less than 1, then a expansion of signals will take place. Similarly, if mod of alpha is greater than 1, so two necessary conditions are there. First one is, if mod of alpha is less than 1, then you can say compression of signal will take place, and if mod of alpha is greater than 1, then expansion of signal is takes place. Why we have written mod? It is just because of maybe this alpha may have a negative values also or positive values also. So here it is mentioned mod of alpha is less than 1. Mod of alpha is less than 1 means what? Your alpha value is actually less than 1, so it can be 0.5, 0.2, 0.3, whatever you want to take, and maybe it is having some negative values also. Similarly, on the other hand, mod of alpha is greater than 1 means what? This alpha is having a value which is greater than 1, that is 2, 3, 4 you can say, as well as maybe it have one negative sign also. Now we'll study this, how this alpha used to compress or expand the signals. Basically, this compression expansion can be done on continuous time signal also, as well as discrete time signal also. So we'll apply this alpha value for continuous time signal also, as well as discrete. First of all, we'll study the continuous time signals, and then we'll study the discrete time signals. So let's see how this expansion and compression takes place on continuous time signals. We are going to apply mod of alpha less than 1 on continuous time signals. Now, as we have studied, if mod of alpha is less than 1, then expansion of signal is takes place. So I'll write here expansion of signals. If you apply or if you use mod of alpha value which is less than 1, then expansion of signal will take place. Let's take one example to study how this expansion is takes place. Basically, how you are going to write this compression and expansion value with function. So this alpha value always comes with the t, that is a time period or a time axis. So it is basically represented like x of alpha into t. This alpha can be have negative values or positive values also, and maybe it is greater than 1 or less than 1 also. In the two right now, what we are going to choose, a mod of alpha is less than 1. So we'll choose let's say a 0.5. First of all, to study this expansion, we'll take one example. That simple one. This is the graph. Now, here we choose the alpha value 0.5. So if this alpha value is 0.5, then what we have said, what I said, expansion of signal will take place. So how your graph will expand? Let's see. Now to understand this concept, we'll substitute values of t from, of course, a 0. But till what? We have to substitute values of t till this x of 1 will occur in our output. Means, let's see how what I said. First of all, we'll substitute the values of t in this function. So x of 0.5 into t. In this function, we are going to substitute values of t, and the t value will start from, of course, 0, because this graph x of t is actually started from 0. So for t equals to 0, how this function will give a response? So if I substitute 0, then I can say that 0.5 into 0, answer is x of 0. Just compare this value with this function. Now x of 0 means what? Amplitude of this x of t at t equals to 0. I will repeat. X of 0 stands for the amplitude of this x of t. Amplitude of x of t, or you can say the height of x of t, but at t equals to 0 instant. So at this is t, and at t is equals to 0 means this is the place. At this point, the amplitude is 1. Means what? For x of 0.5t at t equals to 0 is also having same amplitude. I'll repeat this statement. I have just substituted value of t in this graph. So yeah, after substituting, what I will get? X of 0. Just compare this x of 0 with this original given graph. X of 0 stands for the value of t is 0, and we are going to find out the amplitude at t equals to 0. So look at here, in this graph, at t equals to 0, the amplitude is 1. So that's why I have written 1. So which means for x of 0.5t at t equals to 0, the amplitude is also 1. So at t equals to 0, I'll mark amplitude 1. Let's say this is the amplitude 1. Now, so what I have done, I have calculated t equals to 0 value for this graph, and the amplitude is 1. Similarly, we are going to calculate the next values also, that is for t equals to 0, t equals to 1, t equals to 2. But how many samples of t that you have to choose? You have to select the values of t until you will reach up to x of 1. जब तक यहाँ पे x of 1 नहीं आता, till that time or till that period, you have to calculate, or you have to substitute the values of t again and again. So now I'm going to substitute the next values, that is t equals to t equals to 1. If I substitute t equals to 1, then what I will get? X of 0.5 into 1. Now for t equals to 1, what I will get? X of 0.5. X of 0.5. Now just look at here, x of 0.5 is actually lying in between 0 to 1, and as this graph is continuous, this 0.5 is also having amplitude 1. So I'll write here 1. So now you can say that at t equals to 1, this x of 0.5t is having amplitude 1. So let's say over here you have 1, and the amplitude of this graph is also 1 till 1. So I'll draw a constant line because it is a step wave till 1. Now what after that? Now we'll substitute t equals to 2. If I substitute t equals to 3, this function will give a value of x of 1. As I told you earlier, you have to substitute the values of t till x of 1, that is this instant will appear. Till that time you have to calculate, or we have to substitute the values of t. Now compare this x of 1 value, just x of 1 in at this function, the x of 1 is having amplitude 1. So here I am going to write value 1. Now you can say that for t equals to 2, this t equals to 2 is of x of 0.5. So at t equals to 2, what you will get? Amplitude is 1. So I will draw again a constant line till 2. Now I know that actually this graph is ended over here, but for you I'll substitute a next value, that is t equals to 3. If I substitute t equals to 3, then x of 0.5 into 3 will give x of 1.5. And just look at here, after 1 this graph is having amplitude 0. So for x of 1.5, this 1.5 comes after 1 and it is having amplitude 0. So if I calculate the values of this graph for greater than 2, you will get amplitude which is 0. So actually your graph is up to 2, and after 2 amplitude becomes 0. So as I told you earlier, expansion of signal means what? Your alpha value, mod of alpha value should be less than 1. That's why I have placed alpha value 0.5. And for 0.5, what you will get? The initial original graph is having a period of 0 to 1, but now after applying alpha value 0.5, this time period increased by 1. So that is, in given example, the value is 0 to 1, that is total time period is 1, but after using alpha 0.5, your total time period is increased and it is now 2. And this is called the expansion of signals. Now if we keep mod of alpha greater than 1, then compression of signal takes place. Now how the graph is or signal is compressed, we'll study by taking one example. Now this is the graph. X of t is having a period of 0 to 2 and having a constant amplitude in between 0 to 2, and after 2 your graph is having amplitude 0. Similarly, before 0 also your graph is having amplitude 0. Your graph or this x of t is having amplitude only 1 in between 0 to 2 only. So if I said at what is the amplitude at t is equals to 0.5, of course as this graph is continuous the amplitude is 1, and at 1.5 also your graph having amplitude 1. So the whatever instance available in between 0 to 2 is having amplitude constant, that is 1. Now here I'm going to choose alpha value, that is 2. If I place alpha value 2, then what will be the reaction? That is, I know that the compression of signal takes place, but how this compression will take place, that we are going to study. So this alpha value is now 2. So I'm going to write this function 2t. I'll write all the sequence as it is available on x of t, 0, 1, 2, that's it. Now how this expansion takes place? We'll substitute the values of t until this x of 2 will occur. So let's start. For t equals to 0, where we are going to substitute the t value in this function. So I'll write that value first, x of 2t. So if I substitute t equals to 0 over here, then 2 into 0, we have x of 0. Now just find out the amplitude at x of 0 in given question. In the given graph, x of 0 means what? This is the place of time. So at t equals to 0, this function is having amplitude which is 1. This is the t, this is the x of t. In this graph, we have to find out the amplitude at t equals to 0. So at t equals to 0, this x of t is having amplitude 1. So here I am going to write amplitude 1. I'll repeat. This in this graph, we have to find out the amplitude of x of 0. X of 0 means what? The function is having amplitude at t equals to 0. So at t equals to 0, this graph is having, or this function is having amplitude 1. So I'll write x of 0 is having amplitude 1. So at t equals to 0, this graph is having amplitude 1. I'll draw it later on. Next, we'll substitute next value, t equals to 1. So for t equals to 1, what you will get? X of 1. If I substitute x of 1 over here, then, sorry, if I substitute t equals to 1, then you will get 2 into 1 is 2. And just compare this value in a given graph. So x of 2 stands for the value of t is 2, and t is equals to 2, we have to find out the amplitude in a given graph. So I can say that in x of t function, at t equals to 2, this graph is having amplitude 1. So here I'm going to write amplitude 1. Till how much value we have to find out, or we have to do this stuff? Until this 2 occurs. Now we have already calculated the x of 2 value, which means we have to stop here. जब तक हमें ये 2 वैल्यू नहीं आता, तब तक ये टाइम इंस्टेंट्स का वैल्यू 2 यहाँ पे नहीं आता, तब तक we have to perform these iterations or time scaling operation. Now, as I said, we have to stop here. Why we have to stop here? Because the reason is, if I substitute the next value for t, that is t equals to 2, then what you will get? X of 2. Your result is x of 4. Now, which means we have to find out value of t is equals to 4 in x of t. Basically, this graph is available up to 2, and 2 onwards, that is in this period, or 2 from 2 to infinity, the amplitude is 0. So can I say that this 4 is actually comes after 2 and having amplitude 0? So I'll write here, this is having x of 4 is having amplitude 0. So at t equals to 2, the amplitude is 0. That's why I said we have to calculate this, or we have to perform this iteration until we'll get x of 2 in our output. जब तक अपना x of t के फंक्शन का लास्ट इंटरवल यहाँ पे आता नहीं, तब तक till that time we have to perform the same iterations. So now we have already reached, and what we have got, x of 2 equals to 1. So we'll plot the graph. At t equals to 0, we have amplitude which is 1. So I'll start. Let's say this is the amplitude 1. So at t equals to 0, the amplitude is 1. So here the amplitude, and this is the instant t equals to 0. Now for t equals to 1, the amplitude is 1. At t equals to 1, amplitude is 1. So here also for this instant also t equals to 1, amplitude is same. So I'll draw the continuous graph, a step graph. Till 1. But at t equals to 2, graph amplitude is 0. Means what? We have to stop at 1. And after that, the amplitude after 1 is always 0. This is the graph of x of 2t, and you can say that already the time period. Now just look at here the time period. The time period is 2, but here it is reduced and now it is 1. This is called the compression of signals. So in original graph the amplitude, the time period is 2, but now after using alpha value 2, the graph time period is reduced by 1. This is called the compression of video. Now we'll do the same thing for a discrete time signals also. We'll study the compression as well as expansion in discrete time. We'll study one by one. Now we are going to study a next part, that is discrete time signal, and in that case we are going to study we are going to apply alpha value which is now less than 1. If it is alpha less than 1, then expansion of signal is takes place. Now how the discrete time signals expanded or compressed using alpha we'll study. So first case is mod of alpha is less than 1. So we'll take one example to study the expansion of signals. As we know that the discrete time signal, this t is replaced by n. This t is also replaced by n, and the graph is always discrete in nature. It is not a continuous. So let's take a few samples. At 0, let's say amplitude is 1 in x of n. Now at 1, I'll say the amplitude is 2, and at 2 again I'll write amplitude is also 1. What I've done, x of n is having 3 samples: 0 having amplitude 1, at 1 having amplitude 2, and at 2 at instance 2 having amplitude 1. Now what we have to perform? We have to perform expansion. Expansion means what? We are going to choose alpha value which is less than 1. So let's say if I choose again alpha value 0.5. If I choose alpha value 0.5, then how this x of n is represented? This is represented like this. This is the place of alpha. So we'll write x of 0.5 n. Now on y-axis I'll write the function name, and on x-axis I'll write the sampled value which is n. Now we'll do the same procedure. We'll substitute the values of n until this time instant 2 will occur. Let's substitute value of n from 0 in this x of 0.5 n. For n equals to 0, if I'll substitute n equals to 0 in this function, then what I get? X of 0 means what? We have to find out amplitude of x of 0 in x of n. This place is nothing but the instance place. Instance place means this is the n value. You can say that x of n, in x of n, what is the amplitude at n equals to 0? This is the place of n, which means we have to find out the amplitude of x of n at n is 0. We know that at n is 0, the amplitude is 1. So I'll write for n equals to 0, this amplitude is also 1. Do the same thing for next. I'll take n equals to 1. What you will get? X of 0.5. Now what you will get? If I substitute n equals to 1, then result is x of 0.5. As in x of n, at n equals to 0.5, amplitude is 0. So here also I'll write amplitude is 0. So you can say that at n equals to 0, for x of 0.5n, at n equals to 0, the having amplitude 0. Now we will substitute the next value, that is n equals to 2. If I substitute n equals to 2, what you will get? We'll get x of 1. Now x of 1 means what? We have to find out the amplitude at n equals to 1 in x of n. So for n equals to 1, the amplitude is 2. So here I'm going to write amplitude is 2. Similarly, go for next one, n equals to 3. Now the result is 1.5. Means what? N value is 1.5. We have to find out amplitude at n equals to 1.5 in x of n. 1.5 is actually lying in between 1 to 2, and we can say that, sir, amplitude of 1.5 is 0. So here I'm going to write amplitude is 0. Why the amplitude is 0? Because this graph is discrete. Now substitute n equals to 4. What you will get? X of 2. X of 2 means amplitude. We have to find out amplitude at n equals to 2. We know that at n equals to 2, the amplitude of x of n is 1. So here I'm going to write amplitude 1. Now if I substitute n equals to 5, as we have reached x of 2, means what? This x of n is having maximum time is instance 2, and we have already reached up to that point. So if we calculate further values also, you will get nothing. You will get amplitude 0. So but still we will try. So if I substitute n equals to 5, what you will get? I've already substituted this value. You will get x of 2.5. Just look at here, after 2, in x of n, after 2, the amplitude, there is no function or no graph is present after 2, which means at 2.5 the amplitude is 0. So if you calculate after this level, you will get 0. Means what? You have to perform this calculation or substitution until you will reach up to x of 2 value, till this value. I have already reached at n equals to 4, which means we have to stop. If we move furthermore, then you will get 0 amplitude. So now we'll place all this value one by one. First of all, we'll substitute 0, 1, 2, 3, and last one is 4. So at n equals to 0, the amplitude is 1. Amplitude is 1. Now at n equals to 1, amplitude is 0. So I'll write at 1, amplitude is 0. This is the place 1, and this dot line represents the amplitude is 0. Now for n equals to 2, amplitude is 2. So for n equals to 2, amplitude is 2. Now at n equals to 3, amplitude is 0. So again for n equals to 3, amplitude is 0. And for n equals to 4, amplitude is 1. So this is, let's say this is the 4, and here I will plot amplitude which is 1. So now just look at here the total width or total time period is 2, whereas here total duration or time period is 4. So now you can say that the graph of expansion in a graph takes place if we choose alpha value less than 1. Now for next, if we choose mod of alpha greater than 1, as we know, mod of, if I choose alpha value more greater than 1, then compression of signal list takes place. So let's take one example of a discrete time signal. We'll choose the previous one actually. In the previous example also we have placed the same values and same figure. At n equals to 0, this x of n is having amplitude 1. At n equals to 1, amplitude is 2, and at n equals to 2, amplitude is 1. Now, what is mentioned? Mod of alpha is greater than 1 means what? If we choose alpha value 2, then what will happen? If I choose alpha value 2, then we'll write x of 2n. This is n 0. Now we'll substitute the values of n. So for n, first of all, x of 2n, I am going to substitute the values of n, but in x of 2n. So for n equals to 0, if I substitute n equals to 0 in this function, then what you will get? X of 0. And we know that this 0 is nothing but value of n 0, but we have to find out the amplitude at n equals to 0. So at n equals to 0, this function is having amplitude 1. So I'll write here x of 1. Now, in this discrete case, while performing compression, we have to substitute n values, but in fraction also, for 0.5. If we did not substitute 0.5 value, then what will happen? So let's say if I choose n equals to 1, then you will get x of 2. Means what? You will get this sample value and having amplitude 1. What about these samples? This sample will be missed. So that's why we in this compression we have to always consider the fractional values, but only in discrete format, not in continuous. So if I substitute n equals to 0.5, then x of will get x of 1. If we choose a discrete, if we choose fractional values, then you will get all these samples. If we did not, then one of the sample will be missed. So if we choose only integer values, then you will get x of 0 and x of 2. This x of 1 will be missed. That's why we place n equals to 0.5. So in x of at n equals to 1, this function is having amplitude 2. So here I am going to write it 2. I'll repeat. This is the place of n. So at n equals to 1, in x of n having amplitude 2, that's why I've written 2. Now if we substitute furthermore, that is n equals to, if I substitute n equals to, already we have taken 1. So if I substitute 1.5, so therefore x, if we substitute n 1.5 in this function, so 2 into 1.5, what you will get? X of 3. And we know that after 2, this graph is having amplitude 0. So if I substitute n equals to 1.5, what you will get? X of 3. And x of 3 is not there, which means the amplitude is 0. So where we have to stop? We have to stop until we reached n equals to 2 in our calculations. So we have done this job, and this is the extra work which is not that much important. If we did not follow this third part, or if we did not solve this part, then also it is fine. It is just for understanding. Now we will plot the graph for all these samples. So n equals to 0, amplitude is 1. So here I am going to write n equals to 0, amplitude is 1. Now if I substitute n equals to 0.5, amplitude is 2. So let's say 0.5 is over here, and at n equals to 0.5 you have amplitude 2. Now if I substitute n equals to 1, that is, this is the place of 1. and the amplitude is 1. So now you can say that in given example the total time period is 2, but after using alpha is equals to 2, your graph is decreased and total time period is 1. So you can say that the graph is compressed. So likewise, we can perform the compression and expansion using this alpha value. Now, this was the question. This is the given graph, and the first question is x of minus 2t. X of minus 2t means what? How many operations we have to perform in this question? The first of all, you can, as I told you earlier, we always give first priority to the time shifting property. But in this question, only two application or two properties are given. First one is time scaling, that is alpha value is here too, and another property is time reversal property, or you can say the mirror image or the time folding. So right now, time shifting property is not given, means what? You can perform any property first. You can perform time scaling property first also, or else time folding property first also. I will choose time scaling property first and time folding property afterwards. So first of all, x of 2t. The simplest way to calculate a compression or expansion is just do one thing. Here, whatever alpha value is given, now this alpha value is in multiplication with the t, which means the shortcut thing is just perform the reverse operation. As here the 2 is multiplied with the t, will perform division operation. So you will understand how the compression directly takes place. So if here 2t is mentioned, but if we perform reverse operation, that is if we divide all the time instants by 2, then what you will get? Automatically your graph will get compressed. So just do what I said, just divide all the instants by 2. If I divide 0 by 2, answer is 0, means what? Whatever amplitude is there, now here amplitude at 0 is 0. So here also amplitude at 0 is also 0. Now next one, if we divide next instant by 2, so that is 1 by 2, answer is 0.5. So at 0.5, that is, I'm going to write half, we have a slope. Like in between 0 to 1 we have a slope. So similarly in between 0 to 0.5 also we'll draw the one slope. So now in given graph, the slope is present in between 0 to 1, but if we perform a compression, that is if alpha is multiplied and here alpha value is greater than 1, so of course a compression will take place. Now that's why this 1 is shifted at 0.5. Now similarly, just divide this 2 by alpha factor 2. If you perform the division, the result is 1, means what? Whatever amplitude is present at t equals to 2, the similar will be replaced or remark on 1. So here the amplitude at t2 is 1, here the amplitude at 2 is 1. After performing time scaling operation, now this particle or this instant shifted at 1 with the same graph. As here in between 1 to 2, the graph is constant having amplitude 1. So here also in between half to 1 also the constant amplitude you will get. And as at 2 your graph having amplitude, after 2 your graph is having 0 amplitude. Similarly after 1 also your graph is having 0 amplitude. So just look at here graph having amplitude 0. Similarly here also after 1 your graph is having amplitude 0 till infinity. Now in the next part, what we are going to do in this question, the two different properties we have to perform. First one is time scaling, another one is time folding. So after time scaling property, you can say that your graph is compressed. Now we will perform mirror image. Mirror image means what? Whatever instance available on the left hand side will be shifted towards right hand side with the same amplitude. Similarly vice versa, whatever instance available on right hand side will be shifted towards the left hand side with the same amplitude. Now here we have three different instances are given: 0, half and 1. So all these instances will be shifted towards the left hand side as they are present on the right hand side. So 0 is at origin, that place will never change. Half will now represent on negative side by minus half, and 1 also replaced by minus 1. Now how this graph will look? At my 1 the amplitude is 1 and after 1 the amplitude is 0. Similarly before minus 1 the amplitude is 0 and at 1 as the amplitude is 1, similarly at minus 1 also amplitude is 1. It is continuous. Now in between half to 1 amplitude is constant, that is 1. Similarly here in between half to 1 amplitude is also constant. Now in between 0 to half there is one slope. Similarly in between 0 to half also one slope is there. I'll connect these 2 points by scale. And so this is the result of x of minus 2t. Your graph is compressed as the originally graph is in between 0 to 2 having time period 2, but after performing time scaling operation your graph width is reduced by 1, and after performing time folding operation whatever graph present on right hand side now it is shifted towards the left hand side. Now we will solve the second part of this question, that is x of t minus 1 multiplied by 2. Thank you so much for watching this video. Subscribe this Ekeeda channel. Stay tuned with Ekeeda for further videos. Thank you.